All right, so multiplication principle. So this is very similar to the addition. So if I have A equals B, this is going to be equivalent to A times C equals to B times C. So where we could see like multiplication and a division, or not, sorry, addition and subtraction are like opposites, are operators that go together. So with multiplication, we also have division that will go with us. But just kind of a quick example, if X was say equal to 3, oh, I have that on there. Let me give you something different. X is equal to 5. Well, then if I had, let me see, 6 times X, we know that we'd have to have 6 times 5 on this side. So 6X would be the equivalent of 30. We're going to use this to solve again. So multiplication principle can also help us solve equations. So if you wish to solve X equals 24, we can multiply both sides by 1/6. That's the same as saying division. So another way to look at this is that instead of saying 6 or a number times, so let's say Z times 1/6 is the equivalent of saying that I have Z and I'm dividing by 6. So it's just an equivalence here, but just to show you that multiplication and division are really the same operator. So 6x times 1/6 is equal to 24 times 1/6. Well, we can also say 1/6 divided by 6 is equivalent to 24 divided by 6. So what's going to happen here? Another way we can look at this is that division is just 6x divided by 6, or 24 divided by 6. But you're going to end up with X is going to be equal to 4. This is mentioning again that multiplication division, they are actually the same operator. We just kind of break them up a little bit. So if we divide by 6, same as saying we multiply by 1/6. So showing the same thing here. So quickly remind you about a reciprocal. So the reciprocal of a number is basically being flipped. So the reciprocal of A over B is B over A. So sometimes the other thing that we know about reciprocals is that if I have A over B and I kind of want to just get rid of it, I can multiply it by B over A. That cancels and that cancels, and then you're just left with 1. So A over B times B over A, so a number times its reciprocal always equals 1. That's why if I wanted to get rid of 6, I multiply it by 1/6, because it's essentially, it is, not essentially it is, it definitely is, it's reciprocal. Okay, so 3/4 X equals 15. If I wanted to solve this, I just have to multiply by something that's going to get rid of this 3x. So I'm just going to multiply it by 4 over 3. That also means I have to multiply this other side by 4 over 3. That cancels and x is just left there because we get a 1. And then, well, 15 divided, well, we'll say 15 times 4 is going to be 360. Divided by 3. 60 divided by 3 is just 20. So my solution is 20. So I'm actually going to give you some easier ones here. So you only have one reciprocal here, but you have 4 of them. Well, technically, I guess you can use a reciprocal here too. If you're not sure about B, don't worry, we'll talk about it. But what we're doing here is we're trying to multiply or divide just so we can isolate that number so we can solve it. So just trying to solve all of these. So I'll pause for a minute and come back to the video. Okay, so 1/3 x times 12. Like I said, you could do this I think the easiest way would just be, we got a -3 and we want to get rid of it, so we divide by a -3. That cancels. We got 12 divided by 3, which is 4. We only have one negative, so it's -4. So for B, we're dividing by 2. So to counter the division by 2, I'm going to multiply by 2. So we get x is equal to 8 in this case. For C, we're going to use that reciprocal again. So we got 2/3 x. So I'm going to multiply by 3/2. Remember, you got to do it to both sides. This is going to leave me with an x, and then over here, a -9. Just so you weren't sure. So if you take 3 times 6, that's going to be 18. You divide by 2, that's going to leave me with a 9, and we only had one negative. And then here, this one's going to be a little weird because we divide both sides by 5, and we're left with x is equal to 6/5. So sometimes when we do this, we're not going to be left with a nice integer. In this case, we're left with a rational number or a fraction. I was trying to think for a second what would be, or it'd be 1.2.